Well, there's so many things you can see with binoculars from your own backyard, and even with the naked eye, the Milky Way, particularly this week because the moon is rising way after midnight. So your backyard will be pretty optimal to see the Milky Way this week. Hi, everybody. I'm Marquette. We're so glad you're with us to stay star curious today as the American Space Museum video podcast is on most Mondays, giving you some star lore or something about what's in the sky from your own backyard. And we hope that you enjoy our other programs that we do 5 days a week, Monday through Friday, at about 4 o'clock live every day. Astronaut interviews, a lot of space workers that we call national treasures, and of course, current events as well as what's happening in space history. And we got another biggie this week, Marty. Marty Winkel, my co-producer, as Apollo 15 is going towards the moon right now in 1972, 52 years ago. It lands on July 30th for our fourth landing on the moon with a car, a rover. So we're going to be talking about that tomorrow, of course, because there's only 6 times a year we can talk about those moon landings and get all those hoaxers stirred up and everything, so I can just spend the all week blocking them from our Facebook page, which I do very frequently. So looking here to see who's online today. Chime in if you want, please. I'm going to look at my tablet, go to the American Space Museum, and see if we can pull any of your questions up today. There you are on there today. So going to talk in kind of general terms about the Milky Way, as well as what you can see in the night sky, and why it's important to get yourself away from light pollution. Your backyard, you're trapped there, so you make the most of it. But the faintest that the human eye can see on a really dark desert out in Arizona is 6th magnitude, all right? And you're lucky to see 3rd magnitude from your backyard. Magnitude is a logarithmic scale. That 3rd magnitude is 2.5 times brighter than 2nd magnitude, which is 2.5 times brighter than 1st magnitude. And there's only about 20 1st magnitude stars that you can see from your backyard. So most of the stars that you see are going to be above 3rd magnitude. Think about that when you're getting your star charts. And this is a great time of year to be out in the backyard with a star chart like this. You put your date and time on the star chart, and it mimics what you can see in the sky. With a red flashlight, your eyes stay dark adapted. Another important thing to maximize your time out in the backyard. And of course, binoculars. I see Dave Stange and Mia up there. Hi, Mia, his little granddaughter. Hi, Mia. How you doing? We're going to get you in the backyard and maybe see some meteors with Grandpa this weekend, or this week even. So let's talk about some of this. Behind me is the mural that we have at the American Space Museum that shows the Earth with the thin blue line, and of course the Milky Way in the background, that you would only see it like that in a photograph. And but a couple news flashes today going on is a double meteor shower night going on the next 2 nights. And those meteor showers, and my notes are over there. I didn't even pull my notes off. Marty, they're sitting right in front of me there. We're always doing things at the last minute. Thank you, Marty. Marty's going to go on vacation up in his home area of Long Island, so he'll be chiming in occasionally with us what's going on. We'll get ready for a meteor shower doubleheader, but you're going to have some patience, some tenacity to sit there and just look up at the sky. So you're always going to want to do something. Listen to music, look around with binoculars, and you'll see a meteor in the corner of your eye occasionally. But what I'm talking about are the Southern Delta Aquariid and the Alpha Capricorn meteor showers. They're named after the constellations that they seem to emanate out of. And this is a beautiful picture of time exposure where someone has superimposed their pictures on top of there. In fact, this is Matt Harbison, my friend in Tennessee. Matt is an avid astrophotographer, and this is a combination of maybe 10 different images where each one's got a streak of a meteor on it. And we'll tell you here in just a minute what a meteor is. Well, you're going to hear in the news that Delta Aquariids and the Alpha Capricornids are out tonight. Expect 20 meteors an hour visible. And I say good luck with that because, one, it depends on how dark your night sky is. And from your backyard, you're only going to see the brightest meteors. So that eliminates about half of what they're talking about in the number, because they're talking about ones that are just susceptible to the human eye out on like a New Mexico desert or up on top of White Top Mountain in Damascus, Virginia, where I saw many a meteor shower. So you're going to see a few meteors, but these in the news is always overplayed, okay? It's not like turning on the channel at 9 o'clock and you're going to start getting some laughs by watching reruns of Frasier, okay? The laughs are going to be far and few in between, and sometimes you'll see 2 or 3 meteors within a minute of each other and then wait an hour to see another one. So there's some reasons for that. I'm not going to get into all the meteor shower stuff. We'll talk about that with the Perseid meteors, which peaked in Sunday night, August 11th, Monday morning the 12th. So I'll be up for that, and that is a pretty reliable meteor shower. What is a meteor shower? Well, that is when the Earth, in its orbit around the sun, goes through certain areas where comets have left debris in their wake. Think about like going over a bridge in the summertime of a creek, and your car gets splattered with bugs because there happens to be a lot of bugs around that creek, okay, because that's where the action is. So periodically, very predictably, the Earth goes through debris all over our solar system. Solar system in space is not a void of nothingness, okay? There's a lot of small particles in there from the destruction of other bigger particles in our solar system. And some of the comets leave, of course, debris behind them as it's ripped off by the sun as it gets close to the sun. In fact, 2 comets are the debris source of the Delta Aquariids, are thought to be a comet named Machholz, and the Alpha Capricorns originate from a comet that was recently discovered by a network of automatic comet hunting AI, artificial intelligent cameras, called NEAT on there. So got everybody talking in here. Fox McCloud said that the widow of Ellen Onizuka, Lorna, passed away last night. We send our condolences to her family. And hello, everybody, says Dave Stange. Gary Gerald says hello. Great to see you here in the museum Friday. Carlton Bailey's on. And Dean Babcock says, first viewed the Milky Way at the Grand Canyon. What a sight. And that is probably one of the great places to see the Milky Way. Dave Stange says it's cloudy in Metro Detroit. There's his Detroit City mug glass that you got me, buddy. I'll have a little bit of clear my throat with some Tang. There we go. So glad that you're all joined us today. Tell your friends that they can learn about looking in their backyard and what's up on Mondays on Stay Star Curious. Well, there's a lot of debris in space. In fact, 10 tons, not 10 tons, but 10 tons of debris falls on the Earth every day, all right? From filtering down from meteors that burn up in the atmosphere. An object in space floating around 30,000 miles an hour is called a meteoroid. When it hits the Earth's atmosphere here, it's going to burn up by the friction of hitting that atmosphere. That's called a meteor. And when it falls on the ground and we pick it up, it's called a meteorite, all right? Now, meteorites usually have metal in them. That's how you know if you got a meteor wrong, is if you suspect a meteor in your hand, put a magnet on it. If it is attracted to the magnet, then good chance it is got iron in it and is a meteorite. But also, they feel a little bit heavier than a stone of the same size, and you might have evidence of it had burned up and melted the rock actually during that 30,000 mile an hour entry into the atmosphere. So a dust size, a grain of sand or salt size meteoroid hitting the Earth's atmosphere, that meteor will look very bright and briefly just for like a second. Ones the size of pebble burn up brighter and last a little bit longer. Some even have a little train, a smoky train behind them. We call it a train. So for hundreds of hours, I've laid out in the backyard or on top of mountains or wherever I'm stargazing and looked up at the sky and seen all kinds of meteors. You never know when they're going to happen, but when the Earth is going through a predictable debris field from a comet, like we all heard this week, you're likely to see more of them. You're also likely to see them after midnight. I wouldn't even waste my time looking for these meteors. And I'd get up early about 3 in the morning and lose some sleep and go out at 3 in the morning because the Earth is turned towards our direction of travel. Therefore, things that we're hitting, we're running into. At nighttime, our side of the Earth is turned away from the direction that we're orbiting the sun, and therefore the meteors are kind of catching up to us. So always after midnight and usually before sunrise is when you see the most flurry of meteors streaking across the sky. So here, there's all kinds of ways to observe them without going out in the backyard, and this is an all-sky camera that you can buy and put on your roof. They cost a couple $100. Pipe it into your computer and it records all of the meteors. This is a Perseid meteor shower, and there's a real bright one on the left there, 2 bright ones, that one and the one above. Okay, meaning they were very large or very close to where they came in. So you can see they all emanate from one area of the sky. That's just a coincidence, a vector of whether they come out of Perseus in August or the Orionids coming out of Orion in the winter time. It's like driving down the road during the rain with your headlights on at night, and you see all of the rain is coming right at your car, like you see here in this picture, all right, when it's actually coming straight down or at different angles. It's because of the movement of your car into that storm and rain that it looks like, or snow's also a good one. You get that feeling that they're emanating from a vector point in front of you. A couple meteorites that I own, they're very inexpensive usually. They're sold by the gram, and depending on which meteorite fell on the ground, whether it's a famous one like the Arizona meteorite up in near Flagstaff or other ones around the world. But like I said, you've got $10, $15, $20 each in these meteorites, and they're fun to have. And I carry one around in me. In fact, I got my keys in my pocket here. That I actually have a meteorite to my keychain that's been polished and squared off. Okay, there. So that's actually a meteorite that somebody gave me at one of the talks I did back in the last century, probably. So another cool thing about meteorites is all of this meteorite dust filtering down onto the Earth. If you collect water off your roof in a rain barrel, I tell people all the time, let it lay in there for about a year, then go get a big old magnet, all right? Go to your somewhere where you can buy a pretty good sized industrial magnet and tie a rope on it, stick it down in that rain barrel, go up and down around the bottom of it a few times, don't swish the water up, and you'll pull up some iron filings will be on that meteorite, that magnet. And those iron filings are meteor filings, meteor dust that's collected there. So incredible the amount of debris that does strike the Earth every day. And speaking of things striking the Earth, some people have made a political campaign out of the out of meteors hitting the Earth. So there's somebody that's neither political party, I guess, just wanting to get it all over with here. I understand, Marty, we're just 99 days away from the national election. So, of course, we will not talk about that. We don't talk about politics on our show here unless they cancel the Artemis program. Then we'll talk about it. Noctalgia is a Latin created word meaning sky grief. And that's what amateur astronomers who've been doing this a long time, like me, are really experiencing is noctalgia. It is so hard to see the night sky from any suburban place anymore. It used to be a lot easier, but now where you've got on every horizon a grocery store, a car lot, a hospital, what gas stations just on the loom all around us. They light their sky all night long. And there's different degrees of how dark it is, but this is the Milky Way, of course, you're looking at, our starry arm of our galaxy. And you'll never see it from a suburban area, a big city, and you see the values on the bottom. They call this a Bortle, B-O-R-T-L-E factor. Bortle 1 is very, very dark skies, like Dean Babcock said. He was out there at Grand Canyon, and that's on the far left over there. And then it just falls off a little bit, but appreciably, okay. But you're lucky to see where the 4 is. Between the 4 and the 5, that's suburbia right in there. And I'm going to show you some examples of our Milky Way that you can glimpse at it, but it's directly overhead now. I mean, it's rising, it's sunset, and climbs up higher in the sky. So at 9 o'clock, it's about 3/4 of the way up, 45 degrees above the horizon. Remember, 90 is directly overhead. Horizon 0, so half of 90 is 45, right in there. And then as the night wears on, it's going to be directly overhead, about 10:30, 11. Scorpio's directly south, the heart of the Milky Way. But if you go out and look with your binoculars, you're going to see things that you're not going to see with the naked eye. And you'll start seeing the little cloudy patches of starlight. And those cloudy patches of starlight, for all antiquity, had people confused about what they were. Mythology, of course, centered around it. The ancients of 10,000 years ago didn't know what to make of the Milky Way. Of course, you would see on the far left all the time everywhere you went. So they were very tuned into the sky, and it just had to be breathtaking to see the Milky Way every night from your cave or backyard or wherever you want to talk about it thousands of years ago. But we have to live with it, and that's where telescopes have become so sophisticated that you can see things in your backyard just by downloading an image over and over and over. And that's the cutting edge where astronomy photography is going. Once we started looking up, we wanted to record it, draw it, and then always make photos of it. But until we started photographing galaxies, or photographing things in the sky through a telescope just 100 years ago, our earthling attitude was that everything we knew was in the Milky Way galaxy. Ponder that for a little bit. Here's the Milky Way from your backyard. You're not going to see it very well. This is a subdivision in Tennessee where I lived. I outlined a couple of the bright stars of Sagittarius. In fact, right in the middle is where right the heart of the Milky Way is right there. And I put the words Milky Way up there to show you that you should see it there, but you don't. You got to get away from the city lights because the Milky Way in general is about 4th or 5th magnitude. But now you can barely see the cloudy smoke going through it, much like a campfire burning up in the sky, into the sky. This is from a reasonably dark area called Herky Huffman Park. It is on it's on, I think 192 is the state route that goes out of Melbourne, Florida to the west. In fact, I see the teapot. This is about exactly the same right here that I'm showing you on this picture here. All right. See on the left-hand side is a teapot shaped dot to dot of Sagittarius the Archer. And there you can barely see the teapot. I didn't outline it there, but that's the Milky Way galaxy straight up and down. And here is again seeing it in different areas of the country. Excellent. Out in, of course, on top of a mountain, away from deep sky. Rural, there to the second to the left. Suburban skies, and this is what at least you're going to see a little bit of it, but there's hidden treasures in there in the constellations. That's why you get your star chart to see what things are in there. Globular clusters, double stars, lots of nebula, okay, and a few galaxies like our own. And then city, you're not going to see it at all. Let me make that smaller to emphasize how different it is depending on where you live. Also, when you go outside, get your eyes dark adapted so that you can see your eyeballs open up, just like I've said many times. You jump into the bed at night after flipping the lights off. You don't see anything. In 3 minutes to 5 minutes, you're starting to see things on the walls. In 10 minutes before you doze off, you see everything in the room because your eyes have dilated open. Well, let them do that naturally outside, but don't let any white light get around you to destroy that dilation, and you'll have a better observing time out there. So, all right. Well, let's see here. The Milky Way, give you some ideas. What are we talking about when I say the Milky Way? Well, it is an island of 100 to 400 billion stars. We're not sure what, all right? Because we can't just count them like bean counters. The sun is right there about 2/3 of the way from the center. Yes, we think the Milky Way has these spiral arms and a bar in the middle of it. This is called a barred spiral. All right, I was talking to Eric Baker, our docent today. He said, Mark, how do we know this shape is like this? I said, well, it's all inferred by science. And science looks at what we know and then infers the rest of it by what we predict with physics. So we see one side of it, but we can't see the other side back here because of all these stars are blocking it. And then in the center of our galaxy is a black hole, like most galaxies we think have black holes. Now this is the groundbreaking work that the Webb telescope's doing, that the Hubble telescope started, is to understand how long ago did galaxies start to form in this universe that is 14, let's say 15 billion years old. Okay, so there was a beginning, we think, and we're finding out that galaxies were formed within that first billion years. Really astounding, they think. It's kind of rewriting, again, physics is what we know. So we're there, okay. And again, we think our Milky Way galaxy is like born with all the other galaxies about 13.5 billion years ago, all right, with 200 to 400 billion stars. It is over 100 light years across. From side to side is 100 light years. That's mean at the speed of light would take you, 125,000 light years, or 100 light years. That's our backyard here in our area, the woods here. So a couple things that I find interesting when I'm looking at our Milky Way. This is a recreation of what we think it is looking down on. It's not an actual photograph. It's a combination of some Hubble telescope photographs because we think that we look like several other galaxies out there. And those red areas of this galaxy are where new stars are being born, fresh and red. This is a very active galaxy, all right? Now, we're moving. The Earth is moving around the sun at about 30,000 miles an hour, okay? And then, of course, the Earth's spinning 1,200 miles an hour. We're going around the sun about 30,000 miles an hour. once every 365 days. We go around once, okay? And then our whole solar system is moving in this Milky Way pinwheel, okay? And we're traveling about 450,000 miles an hour around this Milky Way plane, okay? And what I really find interesting is this. If the so that makes one revolution every 250 million years. Okay? Is that right? Is that what I want to say? Yeah. The sun takes 230 million years to complete one full orbit around the galactic center. So one orbit around our galaxy, like a merry-go-round on this pinwheel, is 230 million years to do that once. Well, the Earth is about 5 billion with a B years old. So 5 billion years old, how many times have we gone around and orbited our galaxy? It's like 21 times. All right, so say 20, just for round numbers, we've orbited around there. All right, now we don't know much about what was going on even yesterday, okay, let alone hundreds of millions of years ago, but we do know this. Dinosaurs lived on the Earth for around 165 million years. All right, we know they went through some extinction a little over 60 million years ago, but they thrived for another 100 million years. Okay, before that, thrived 100 million years. Now we talk about modern man is only about civilized man as we know it is 6,000 years old, but our type of humanoid forms that they think have been on the Earth for 6 million years, they're saying. I'm not so sure about that. But more, we evolved into humans 200,000 years ago. Now think of the pyramids are 4,000 or 5,000 years old of Egypt. But civilization, you could say, is about 6,000 years ago old. All right, so back to 4,000 BC, maybe 10,000. So we'll give it a little more time. And of course, the industrialization of the world just began 200 years ago. Think about that. So how little we know and how much time we spent orbiting around our galaxy on this third rock from the sun called Earth. Now, some people ask, are there any other suns in the Milky Way galaxy? Yes. Our sun is just the name of our star. All right. Sun is just a regular star. All right. It's like saying Mark or Marty, okay, or Logan. We have to give things names. All right. We say Mars, Jupiter, Sun. We say moon, but there's other moons in the solar system, like over 250 moons in the solar system. So, but I'm just trying to get your head wrapped around like 20 orbits since the formation of the Earth around our sun, and there's got to be patterns out there. This mass extinctions could be caused when we're rotating around our pinwheel. When we're on this side of the Milky Way, we might be exposed to something coming from outer space when we're not exposed to when we're up here or over here. Okay, so there could be bumps in the road, so to speak, in our galaxy. We've got things called dark matter out there and warping time and space. So, well, we do know, again, edge on. Here's what we think our view of the Milky Way is looking above it, okay? And then the Milky Way edge on looks like that. We're very thin, okay, less than 1,000 light years thick, but over 100,000 light years wide, all right? Which begs the question, Marty, really a serious question, how much chocolate is in the Milky Way, all right? How much of it's chocolate, how much of it's nougat, and how much of it's caramel? Scientists want to know. I'll bet Mia wants to know. All right, Dave Stange, give your granddaughter a Milky Way there for being a good girl. So, well, here's a guy rocking a pipe that you don't see very often. That's Edwin Hubble. We've talked about Hubble many times, and he's the reason why we stopped thinking that the Milky Way was the entire universe. We looked out in our backyards and they could see with binoculars and, of course, telescopes 100 years ago that there was individual stars in this Milky Way. There was clouds, a lot of gases. All right, the dark areas are actual cloudy clouds, interstellar clouds that are creating other stars inside them. And then there was this object called the Andromeda Nebula. All right, and the Andromeda Nebula, even in a telescope with the naked eye, it looked just like a nebula, diffuse. Here it is, and it's on the left-hand side is the Andromeda Nebula that they could not resolve the individual stars in it. All right, and when Edwin Hubble took the first images through a 100-inch telescope here behind me, all right, in 1923, 100 years ago, this was the picture Hubble took, and individual stars started appearing there, including a variable star called a Cepheid variable, which its light is predicted to change off and on in a predictable manner. Then Hubble determined this galaxy, it's a galaxy like our Milky Way. It's not a nebula. This is another aggregate of millions and billions of stars, just like our Milky Way. Then it was headlines. Other universe discovered beyond our own universe. This was the thinking, seriously, just 100 years ago. Look at that picture of Hubble that made him famous, October 1923, right there. Variable star with an exclamation point, all right, because he would go back and photograph this, and he knew by what is now called the Hubble constant with a spectroscope in redshift theory, the redshift on a spectroscope, that this was over 2 million light years away. All right. And in the fall, we talk about the Andromeda galaxy, that you can see it with your naked eye. And it's the farthest thing the human eye can see with the naked eye. And it's pretty bright. It's about third magnitude. You can see it in your backyard very easily. So there's a spiral galaxy, and then in the upper left-hand corner in this photograph is an elliptical galaxy. And we'll talk about galaxies here in just a minute. But the Hubble Space Telescope took this picture above of the inset, see under the right there. And the other inset's what Hubble took through a big 100-inch telescope in California. And this started his claim to fame. And then he used the 200-inch Hale telescope to define more of the expanding universe. And every galaxy he saw was going away from other galaxies for some reason. And so great breakthrough. And this is the heady stuff of cosmology today. So once we discovered another universe in our backyard, the Andromeda Nebula became the Andromeda Galaxy, then other fuzzy objects were starting to be photographed until 100 years later, we know that there are billions of galaxies with hundreds of billions of stars, and most of those stars having probably planets going around them. All right. In fact, they figure there's more than if there's 200 billion stars in our Milky Way galaxy, they figure there's at least that many or more planets orbiting them, because the planets we're finding orbiting nearby stars number into the 4, 5, or 6, just like around our sun. Well, every object here, except that one that's on the far right there that's got spikes through it, that's the ones that have spikes through it are stars between us and these galaxies. You can't even count them there. Everything in there is a galaxy of different shapes, sizes, and different periods of time in our universe created. There's about 4 or 5 different types of galaxies that can be then broke down into other kinds. You got the spiral, like the pinwheel, the barred spiral. It has a bar going across the center of it. That's what we think our Milky Way galaxy looks like. This is from the discoveries of the orbiting observatories like Chandra, launched 25 years ago by Space Transportation System Shuttle number 96. Lenticular, okay, not necessarily edge on, but they are drawn out like a cigar or cigarette maybe. You have elliptical, and then you have irregular galaxies here. Irregular are that they're stars that are clustered together We don't know what happened to make them irregular and kind of haphazard. Elliptical are very spinning in a tight mass in there. But spiral, the barred spiral, and the elliptical are the most common of the galaxies out there. Well, let's take you out back into the backyard again. But this is the backyard of the dark skies of Texas, where I was privileged to be several times at the Texas Star Party out there by the National Forest. McDonald Observatories out near there. This is in the chin of Texas, in west Texas there. So nothing done here, but just leave the camera open for about 2 minutes exposure. All right. Maybe I think I had a timer on it. You see the trees moved a little bit, so I was following the motion, but so spectacular to see it rise up overhead. And you see galaxy clusters here, different things. There's a neat little cluster right above the horizon, a ball of stars. But this is what you're going to lucky to be seeing from your backyard. And when you do a time exposure, which I encourage you all to do, put your camera on a tripod, put the sensitivity ISO to as high as you can go, maybe like 5,000. Don't go all the way up high. Go like a couple notches back from, it says 5,000, go to 2,000 ISO. And a tripod, and take a 30-second exposure. All right? And you're going to get some Milky Way going on here. In fact, right at the upper top is a globular cluster that's in Sagittarius. Again, without cloud, what I want to show you here is you see clouds in there. And the clouds can be really cool in your photo, but you don't realize the clouds are there when you're stargazing, okay? So that can also, a thin, high alto cirrus clouds can linger for a half hour or so, and you think it's a bad night of observing, then all of a sudden it clears off. I can't emphasize enough the patience of staying outside and waiting for something to happen, particularly during meteor showers. You're just not going to go out there and in 10 minutes start seeing meteors. One, your eyes need to dark adapt, and then you need to protect that so that they don't get any white light flashed on them and then degrade your vision again. You have to build back up to light sensitivity of your eyes. But also just there's always something going on up in the sky, usually airplanes. A lot of us live near airports. See that little green flash in the upper left there? I'll show you a couple more of those here in a minute. There's another one. Well, that's a UFO, Marty and Logan, that I photographed bopping around there at Herky Huffman Park. But no, that's actually a lightning bug in my photograph, okay? And right below that lightning bug, you see a series of dots, okay, light dots there. That's an airplane, and the typical flashing of an airplane light, all right, for about 30 seconds. But look at that Milky Way in the middle there. Now, you take a picture like this. Let me go back to, and this has some Photoshop to it. Basically, you put more contrast in the photo, play with the highlight bar a little bit, make it as dark as you can get it, and that'll punch it out a little bit more. So I see a couple lightning bugs in there. There's some right there, and another set of them going in there. Here I have out at Herky Huffman Park in a vertical in the Milky Way, the dark cloud right there. There's an airplane. There is another airplane, on the bottom. Okay, you can see the lights blinking off and on there. But up at the top, that's a meteor. I caught a meteor. Yay! You can tell because it's streaked. Okay, see how it's thinned out? Right there, yep, there's a meteor right there. So that's probably about second magnitude. All right, a pretty bright one where the stars there around the clouds of the Milky Way are second and third magnitude. That's almost the first magnitude there. So you'll see satellites, a lot of satellites in the sky, and of course the International Space Station. I want to make a note here. I want to tell you about I want to tell you about Hurricane uh, Irma in the Milky Way. Hurricane Irma in the Milky Way. Make a note of that, Mark. Well, here's a pretty good shot of the Milky Way out there in those really dark, dark areas up there. And the Milky Way, you're going to see the constellations that you can't see because of all the stars here in the Milky Way. And we're looking, the brighter it is, it's the center of our galaxy where there's more stars piled on top of stars. But there are three bright stars, one at the top, one to the left here, okay, and then one to the far left. Those are the stars of the summer triangle. Very easy to see. Let me make that smaller, Logan. You do a dot to dot between Vega, Altair on the right, and Deneb on the left. Again, I go back there. Deneb is on the far left there. Barely see it. It's the fainter of the two. And then you put the triangle on top of them. The summer triangle. And so that's a fun thing to look up. Vega is part of Lyra the Harp up in the sky. And Deneb is part of Cygnus the Swan. We'll talk about them next week on Stay Star Curious. And then Altair is in the Eagle, Aquila the Eagle. But they make up all three of them, and that's easy to see. Go out when it gets dark, look up in the sky to the east. To the east where the sun rises, and you're going to see three bright stars sticking out. Okay, and they're in three different constellations, and the Milky Way straddles right in the middle of them. And here's another Milky Way shot that I took out there at the Texas Star Party. Really one of the darker sky sights in the country still. There's a big star party at the Texas-Oklahoma border too. But we're losing the battle, noctalgia, the grief of losing the night sky. And, why, Mark? You just go, why? What's the big deal about losing the sky? Who needs to look at the Milky Way, all right? Who needs to see the stars in the sky? I'll tell you who needs to see the stars in the sky. Hundreds of species of animals, insects, mammals, all kinds of creatures on this planet actually navigate by the stars, all right? And also the nocturnal creatures that are used to hunting in the night or so they don't get caught, like little mice hunting around at night. They don't during the daytime because, their prey see them very easily. They depend on the night. So robbing the night of creatures on the earth is very similar, though you might laugh at this, but no, it's very similar to global warming. Okay, it is a thing all of its own where species of insects and mammals are being eliminated because their normal nocturnal night habits are being interfered with and they can't adapt. And I'm going to put a program together on that one day on there. So, but losing the night and illuminating it all the time is a thing just like global warming. Okay, there's some creatures don't get the sleep they get, for example, or they become prey when they shouldn't be because of the lack of dark areas in the sky on there. So, all right. Hope that you're enjoying getting out in your backyard and looking at the Milky Way. Know how well you can see it. Encourage you to get out and look up. Here's a galaxy taken with the Hubble telescope that's showing you the red areas there. That's where new stars are being born, all right? And this is another galaxy similar to our galaxy, we think. And the Webb telescope took this a step further with this and shows us deeper inside and a black hole in the middle there. Yeah, that blue is there for some reason. This is like an X-ray looking into it, into the infrared, and an X-ray looking into this galaxy. And the empty spaces here that you see, at first you say, well, these empty spaces are empty spaces, but they're kind of circular, aren't they, Logan, there? And what you need to think about, these are gigantic galactic gas bubbles created by all the what's going on in this galaxy. It's an alive thing that's creating stars. It's stars are but we don't see many stars blow up in galaxies, okay? One or two a year probably blow up in each galaxy. So stars really last a long, long time. So remember, as we go out into the backyard and you look up, that there's more than meets the eye. These is an area of the sky in the Big Dipper. And the Big Dipper's now almost dragging along the horizon, though you can see it early in the evening to the west of the North Star Polaris. But this is an actual photograph with a galaxy in the foreground, several in the foreground, and look at all these in the background. Spirals, lenticular, irregular, okay, barred spirals, and elliptical, all shapes and sizes. Another, if you counted them, another 300 galaxies in there that they're looking back at you. We just can't see them in the night sky, but we can see a little bit of our own arm of the Milky Way there that we look at and see so beautifully. And though you might not see it as beautifully as going to the Grand Canyon like Dean Babcock did, okay, it's still something to enjoy as much as you can there. So get out, enjoy a little bit of that starshine out there. Hello to Steve Jokums. Why didn't we ever name our moon something, Dave Stange said. Well, I've talked about that a few times. Some cultures did, La Luna. We should just call it moon, not the moon. We don't say the Dave or the Mark. So, and Tommy UCX watching, thank you. Carlton Bailey's reminding us of a 6:45 Monday launch of a very important top secret satellite for our Defense Department on an Atlas V rocket. That's at 7:15 tomorrow morning. I might get up early for that because that's right around sunrise. And you could really have some beautiful photographs of that there. Well, my story about Hurricane Irma and Orlando. All right, imagine this. This was on the news shortly after Hurricane Irma. Hurricane Irma knocked out electricity around here, and particularly Orlando, for 3 days. A lot of Brevard County and Orange County, where Orlando is, was without power after Irma. September, 2017, I think it was, 7 years ago. My first hurricane and only really big one. So about the second night, when they didn't have electricity in downtown Orlando, the fire department was getting phone calls about a fire south of town. They logged over 20 phone calls of people saying, south of town's a fire. Well, where? They didn't know exactly where, and the fire department finally figured out that what the people were reporting as a fire was the Milky Way. They'd never seen the Milky Way, okay, in downtown Orlando or suburbs of Orlando. So true story, and you can kind of get a hint of that right there, the smoke rising off the southern horizon of the our Milky Way galaxy's arm there. So, well, I'm going to go get me a Milky Way candy bar and just see how much chocolate's in it. Don't know about you all, but tomorrow we're going to be talking about, I don't know about you all if this talk made you hungry for a Milky Way. Don't get a Snickers, okay? There's no peanuts in the Milky Way. Only caramel, nougat, and chocolate. So tomorrow we're going to talk about a great moon landing that is one of my favorites. I think it is my favorite, Apollo 15, just where they landed. We've got a lot of personal connection with that story with one of our volunteers who's no longer with us. Trained the astronauts to land there. So you're going to enjoy that. And we're going to even maybe look at little Doug Forrest artwork. Hi, Doug. Thanks for watching. But Doug Forrest did some great artwork of the Apollo era on there, and he's got several unique pieces that we will showcase tomorrow, Doug. So thanks for watching. Dean Babcock, Fox McLeod, Bill Whiting, Dave Stange, Gary Gerald, Carlton Bailey, Mitchell Rothman, who's manned space, Steve Jokins, and Tommy Usiak. We're glad that you're all going to get out in your backyard and look at the Milky Way. If you can't see it because you're just too much suburbia, go out there with the binoculars and look around a little bit. You'll see some faint light patches out there of our own galaxy. So thank you, Logan, for a good job on our Streamlabs, and Marty, thank you for all that you've done here the last 4 years to help promote and help us reach out to everybody on Stay Curious. So until tomorrow, when I'm going to be a lunatic about Apollo 15, I'm Marquette saying I can't wait to see you in our backyard to bridge the space to the stars between us.